Hello everyone, welcome to another tutorial on 3G 4G channel. In this one, we will look at what is meant by non-terrestrial networks or NTN. If this is an area of interest, you may also want to check out our old tutorial on connectivity in planes. There is a slight overlap in this one with that one, but hopefully not too much. So let's start with terrestrial networks. Now this is mainly to help non-native English speakers to understand. Terrestrial means ground-based or earth-based. So terrestrial mobile networks are mobile networks based on the ground that we all use. While we could say that terrestrial networks are 0 kilometer above ground as they are earth-based, the cruising altitude of planes is typically between 9 and 11.5 kilometers above the earth. So I am showing this just so that you get an idea. When we actually look at the other non-terrestrial networks, you would get an idea of for comparison purposes. So satellites on the other hand are much higher as compared to planes. Geostationary satellites or GEO are located 35786 kilometers above Earth. This allows them to appear in exactly the same location above the Earth. Then you have MEO or medium Earth orbit and LEO or low Earth orbit. So MEO is typically between 7,000 and 25,000 kilometers, while LEO is typically between 300 and 1500 kilometers. LEO are particularly important as there are so many different companies trying to launch internet from space. Now, these are some of the mega constellations, as they are referred to, that are planned to be operational soon. OneWeb, SpaceX, and Telesat are well known. There are others like Amazon, which is planning to launch around 3,236 satellites as part of their Project Kuiper. And Facebook formed a company called PointView that is testing small CubeSats for satellite internet. So we don't really have, or at least I don't have much information available on these things yet. So hopefully when more information is available, we can compare all these different types of mega constellations. This is also a good summary of three well-known LEO mega constellations, the Telesat, SpaceX and OneWeb. I'm not planning to read the entire thing, but the slides will be available with the source of this presentation. This is just to give you an idea on how the LEO satellites work. So let's quickly look at how satellite connectivity works. It is important to remember here that the same principle applies not only to LEO, MEO and GEO satellites but also to unmanned aircraft systems or UAS and high altitude platform systems HAPS. So we will look at UAS and HAPS soon. So to communicate with satellites, you need some kind of a backhaul from the ground. This is known as satellite gateway or earth stations. The communication link between the earth station and satellite is known as earth station communication link. The satellite can now start transmitting. This transmission will cover an area which is shown in pink here. The satellite phones can work directly where satellite coverage is received. Now it is important to remember here that all different satellite systems transmit different waveforms, signals, messages, etc. So there is no standard in satellite transmission like mobile standards. So a satellite phone for each type of satellite constellation would be different. A mobile phone cannot directly work with the satellite. There is a possibility that phone can work with the satellite in future if it's transmitting 3GPP standards based signal, but this will only happen with a LEO satellite because there is a limit on how much power a mobile phone can transmit safely from a user's point of view. This means that it may be possible for uplink signal to reach the satellite. Bear this point in the mind because this is what makes UAS and HAPS appealing. You can have a terrestrial base station that is backhauled on satellite signal as shown here. The base station would need a satellite transceiver to communicate with the satellite. You can now have mobile phones communicating with the base station. In case if it helps, the red lines show how the messages flow between the mobile phones and the network in case of satellite backhaul. So finally, we have unmanned aircraft system or UAS, which typically fly at an altitude of between 8 and 50 kilometer. Note that 9 kilometer will be below the aircraft altitude. Hence, the typical range for UAS is between 18 to 27 kilometer. The high altitude platform station HAPS is a type of UAS that typically operates at an altitude of 20 kilometers. You can see different types of HAPS here, including the Google Loon, unmanned drones, etc. Typically, they all operate around 20 kilometer. Now, let's get back to 3GPP standards. Adrian Scrace at CTO and head of MCC at 3GPP did a presentation back in March at Critical Communications Europe conference. This roadmap is from that particular presentation. As most of you are probably aware, satellite has long been used in conjunction with mobile networks, although being limited to supplying backhaul for the access networks, typically in rural and remote areas, where other forms of backhaul are often difficult to provide. The satellite industry, on the other hand, has long desired to use satellites not just for backhaul, but also for access networks. So, based on this expression of interest by satellite industry, the initial 3GPP release 15 version of the particular specs, so the 3GPP technical specification 22.261, which is the service requirement for 5G system stage 1, added initial requirement that 5G system will be able to provide services using satellite access. So following that, a study was carried out by 3GPP as a part of 3GPP release 16, and the results of the study on using satellite access in 5G networks has been documented in another 3GPP technical report called the 22.822, which is study on using satellite access in 5G stage 1. Now don't worry, I will provide references at the end of this presentation, so you can look and download the specs yourself. So this particular document 22.822 details the use cases, pre and post conditions, service flows, potential impacts, interactions with existing services, features, and potential requirements based on different use cases. So the results from this particular technical report were then reflected in 3GPP release 16 version of the same specification, right? The 22.261, but the release 16 version. Now, this new document details the need for 5G system to support service continuity between terrestrial 5G access and the satellite based 5G access owned either by the same operator or by an agreement between operators. So while satellite is a type of non-terrestrial access network, it was felt that there are other types of non-terrestrial networks which have an overlap with satellite use cases, requirements, etc. As a result, the scope was expanded to cover kinds of spaceborne and airborne vehicles into a single umbrella of non-terrestrial networks or NTN. 3GPP TR 38.811, which is the study on new radio to support non-terrestrial networks, provides a characterization of satellite access as a result of 3GPP TSG RAN study. So you can see from the roadmap that there are lots of features that are planned in release 16 and 17. The specs are not completely ready and I don't have the latest information. So I will skip going into them in this particular video. Hopefully a new video in future with the details will be released. So we already looked at what is meant by non-terrestrial networks. 3GPP defines NTN as networks or segments of networks using an airborne or spaceborne vehicle for transmission. So spaceborne vehicles would include the LEO, MEO, GEO as well as the highly elliptical orbiting or HEO satellites. Airborne vehicles include the high altitude platforms (HAPS), which encompassing unmanned aircraft systems (UAS), including lighter than air UAS (LTA), heavier than air UAS (HTA), all operating in altitudes typically between 8 and 50 kilometer quasi-stationary. So quasi-stationary basically means they are not stationary, right? But they are not moving away far off. So they sort of like keep on coming back to the same location, like in like a periodic or an aperiodic fashion. So 3GPP TR 38.821 includes the description of next generation radio access network or NGRAN reference architectures supporting various NTN scenarios. So the three main architectures under consideration are a transparent satellite based NGN RAN architecture, regenerative satellite based NGN RAN architecture with G-Node B on board, and the third one is regenerative satellite based NGN RAN architecture with GNB DU on board. So let's pause here for a second. You see, in the third point there is a mention of DU or distributed unit. I have not covered this topic before, so let's look at it very briefly. So in case of 4G, we had this concept of BBU or the baseband unit and RRU or RRH, which stands for remote radio unit or remote radio head. So for people who may not have encountered these terms before, BBU and RRU make your E node B, okay, in 4G. So in case of G node B, instead of BBU, we now have CU or the central unit and DU, the distributed unit. In terms of what the CU and DU contains, there are many different types of combinations possible depending on different splits, as can be seen here. So I will someday do a separate tutorial for this, but this should give you an idea what the CU and DU contains. Just remember, CU stands for central unit and DU for a distributed unit. So coming back to the satellite architectures, the first architecture option is transparent satellite based NGN RAN architecture. So in this case, the satellite or the non-terrestrial network acts like a repeater, repeating whatever signal is received, right, from the G node B located on the ground. The second architecture option is regenerative satellite based NGN RAN architecture with G-Node B on board. So here in the first case the G-Node B was on ground, but in this case the whole of G-Node B is located on the satellite or the non-terrestrial network. So the satellite radio interface or SRI carries the next generation interface. So the picture is shown without any inter-satellite links to other satellites, but this architecture would actually allow uh, communication between different satellites over the XN interface. And the final architecture option is the regenerative satellite based NGN RAN architecture with G-Node B distributed unit on board. So this architecture takes advantage of the NGN RAN logical architecture with CU-DU split, right? Like the one we discussed in earlier slides. So the central unit is located on the ground while the distributed unit is located on satellite or the non-terrestrial network. Now this architecture also allows for DUs on board on different satellites to be connected to the same central unit on the ground. So that is one of these additional advantages with this particular architecture option. So this slide is from 5G World back in June. While I'm not an expert in 5G standards and their timelines, my understanding and some of the summary documents from the RAN plenary is that due to tight deadlines for 3GPP release 16, priority is being given to study of the set of necessary features and adaptations enabling the operation of new radio protocol in NTN for satellite access. So UAS, including HAPS-based access, could be considered as special case of NTN, of the non-terrestrial access, with lower delay Doppler values and variation rate. Targeted usage scenarios with satellite access are pedestrian, stationary in building, onboard vehicle, high-speed train or airplanes. So stationary in building, onboard vehicle, high-speed train or airplanes usage scenarios may require a relay UE. Okay, so a relay UE is basically a UE that actually can receive information from the satellite, because you remember I explained it before that a normal mobile phone cannot receive signal from the satellite, but you need some kind of like a bigger UE with some kind of a satellite receiver, and that is referred to as relay UE. So the priority of release 16 study is on pedestrian and onboard vehicle usage scenarios. The possible reference scenarios and architecture options for NTN will be identical, right? And they will be described once all the scenarios for satellite has been discussed. So, however, the scope of release 16 study item will be limited to key issues and solutions associated with transparent geosatellite and LEO based non-terrestrial access network. So, moving beams on Earth. Right? Why do I call it moving beams on Earth? Because you remember when I showed that the picture of satellites, geostationary satellite is fixed. So the beam is stationary at one location, but LEO keeps moving. So you know you don't have a beam at a constant location. The beams are actually moving. And some advanced complicated features like the integrated access and backhaul, as well as combined operation of GEO-LEO networks for idle mode are not really being considered during release 16 at all. So some of these things, advanced features, have actually been pushed to release 17, right? So you know only basic scenarios are being considered for release 16. So let's finally look at some use cases and applications. So today you lose connectivity when you go on a plane or high-speed train, ships, etc. From a user point of view, satellite connectivity can ensure that you have continuous connection. Now this use case is tricky to implement and may not really happen for a while. This is an interesting use case as when ships are out in the ocean, even today, they have only satellite connectivity. With new satellite constellations and 5G, the connectivity speeds can improve along with the user experience. Also, today the costs are too high, so they will have to come down eventually. Emergency and public safety communications can really take advantage of high speed, ubiquitous connectivity. All the rural, remote, unserved and underserved areas could be helped with satellite connectivity. Connectivity for M2M or IoT devices is going to be a really useful feature, for things like tracking the containers, etc. etc. And the 3GPP TR 38.811 has a lot more use cases defined in section 4.2. So, you know, if you want to actually look at all the use cases which are being thought about in 3GPP, you can go to this particular document. So here are the references for further reading. So you can actually go on the 3GPP website and you can download probably the latest version of the specs to see what's going on, because a lot of these specs are actually undergoing revision every month or so, because things are changing so quickly. So hopefully this was a good short introduction to what is being referred to as non-terrestrial networks in 3GPP. So in the next year or two, we will see a lot more activity on this feature and hopefully start seeing some pilot deployments as well. So as always, feel free to leave comments, suggestions, etc. in the comments below. Please subscribe to this channel and also help us promote it. So all your help will really be appreciated. Thank you.